Let's continue our discussion of quadratic functions. We've been thinking about this standard form of the quadratic function formula, f of x equals a times, I guess it's the first time I'm giving it to you in general. So f of x equals a times x minus h squared plus k, where a, h, and k are numbers. So the vertex is always going to be the point hk. Notice how there's a minus sign for h and a plus sign for k. It kind of reflects the transformation rule, right? Because h is a shift to the right, k would be a shift up. If k is minus, we go down. If there's a plus sign in parentheses, we'd shift to the left and not the right. So the vertex is hk. And also, if a is greater than 0, then the shape of the graph is U-shape. But if a is less than 0, if a is negative, then the shape is like an overturned U, because when a is negative, we'd have a transformation of reflecting through the x-axis. So the parabola gets flipped through the x-axis. Now, we're not going to rely on the standard form too often, but I want to do just one exercise where it comes in useful so you can see that. So this is our official exercise 1, similar to a homework problem. Find an equation for the quadratic function whose graph is pictured. And so I have a rough sketch here. Notice 2 points are labeled, so we have 2 points on the graph. And to make this work, you have to notice that 2, 5 is the vertex, and that's not supposed to be a mystery, so the picture should be drawn in a way where it's obvious that that's the vertex. And so we're going to use that form f of x equals a times x minus h squared plus k, because that's useful when you know the coordinates of the vertex. I can just plug in a value for h and a value for k, and so I have f of x equals a times x minus 2 squared plus 5. And so we still need to find a value for a, the other constant in that formula. And we can get a value for a using the coordinates of the other points. We're going to use 4, 3 to help us find a. And now we're going to interpret 4, 3 as telling us that f of 4 is equal to 3 for this function. F of 4, using the formula, is also equal to a times 4 minus 2 in parentheses squared plus 5. So this f of 4 that I get from the formula, I can set equal to 3, y coordinate 3. And now I can solve for a. 3 equals, this is a times 4 minus 2 that's going to be 2 squared plus 5, or 3 is 4a plus 5. So a little bit of algebra here. I have to subtract 5 from both sides. I get negative 2 is 4a. Negative 2/4 is a. That's negative a half. And I have my a value. So let's just go ahead and write our equation down, or formula, you could say, for the function. That's f of x equals negative a half x minus 2 squared plus 5. That's the answer. So that's, again, a formula for the pictured quadratic function graph. Okay, now let's go on to the next page here. And what I want to do is really, we want to be able to work from that ax squared plus bx plus C form of the formula for a quadratic function. And the one thing we don't get easily from this formula are the coordinates of the vertex. That's what that standard form is useful for. So I'm asking this question. If we start with the ax squared plus bx plus c form, how can we find the coordinates of the vertex? And what we're going to do is we're just going to derive a formula for the coordinates of the vertex. So let's go ahead and take that f of x equals ax squared plus bx plus c. And what I want to do is I want to imitate what we did in that first example where we completed the square, right? We wanted to factor a from the first two terms. And now you may look at this and say, well, there's no way you can factor an a from bx. But it turns out you can factor an a from any term if you learn a little trick in algebra. And here's the trick. I'm recopying the beginning of that. Now, what I'm going to do is I'm going to take that the bx, and I'm going to multiply and divide by a. So I'm going to take a times bx over a. So I changed the look of that bx, but because I multiplied and divided by a, this is still equivalent, right, plus c on the end. And that allows me now to have an a that I can factor out. So that's the trick. Multiplying and dividing by a, I'm going to factor out an a from those first two terms. Now, this a and this a are both replaced by the a out in front, but the a in the denominator stays behind. So I have that bx over a form. And you can just check, just distribute, and notice it'll take us all the way back to where we started. Now what I want to do is I want to add, I can write that as b over ax. I'm going to add something inside parentheses in order to complete the square. And what I need to do is take that coefficient of x, the b over a, and I need to divide by 2 and square what I got there. So b over a divided by 2 is b over a times a half squared. That's the same thing as b over 2a squared, or b squared over 4a squared. So a little bit messy. I'm going to add b squared over 4a squared inside parentheses plus c. Now I have to subtract outside to compensate, and I don't just subtract b squared over 4a squared because I have to take a times that. So I have to subtract minus ab squared over 4a squared to compensate. You won't have to reproduce this, so don't panic. Just try to get the gist of it. Now we want to be able to factor inside parentheses, and it's going to be x plus x plus. You can take square roots, and b over 2a is going to work. I have plus c minus, I can cancel an a there, so I have b squared over just 4a. And now I have a times x plus b over 2a in parentheses squared plus c minus b squared over 4a. So kind of a big mess, right? And yet there's only one thing we need to get out of this, and it's right here inside parentheses. We're almost all the way to that standard form. So if you think of the standard form, inside parentheses is the x-coordinate of the vertex. But now you got to think of this in the form minus sign, or I don't know, like you could think of it as x minus a negative b over 2a squared plus c minus b squared over 4a. Because the standard form depends on there being a minus sign in the formula. So the x-coordinate of the vertex is minus b over 2a. And some people memorize that as a formula to use. In fact, we're not in this video, but in the next video we're going to go over this box down at the bottom where we're actually going to have our official steps to go through in graphing a quadratic function. Just one more thing I want to say about this x-coordinate of the vertex. Just compare to the quadratic formula. This formula we just got for the x-coordinate of the vertex. Quadratic form is that negative b plus or minus square root of b squared minus 4ac all over 2a. If you cross out the plus or minus and the square root sign, you end up with negative b over 2a. That's actually the same as this formula for the x-coordinate of the vertex that we just got. So, and there is a connection there. There really is a reason why those come out to be the same. Okay, so I'm going to stop here, and we're going to go over our summary of how to graph quadratics in the next video, and we'll do an example of exactly what I want you to know how to do.